Hello and welcome to Chords and Arcs for circles. There's a couple theorems that we do need to know when it comes to arcs, and they're chords. So let's just jump straight into it. So if we have congruent central angles, so let's draw a circle. There are two theorems affiliated with this. Okay, so here's our first circle. Let's go ahead and draw a diameter through this. Let's call this A. And then let's draw some chords. Draw two different endpoints here. You're going to draw the points for the diameter. Let's call this D. Let's call this E, F, and G. No, I don't know why I didn't use ABC. Let's go through ABC. So A, let's call this B, C, D, and E. So this is a little bit easier. So I'm going to draw a chord from B to C. I'm going to draw another chord from D to E, and then I'm going to draw some radii. Now, I should have drawn this a little bit better to scale, but let's assume that this angle here is 50 degrees. I know it looks like a right angle, but just bear with me, 50 degrees. And let's say DAE is also 50 degrees. Well, a couple things happen. Okay, so here's our theorem. We use this for congruent central angles. As you can see, our central angle is congruent in both cases. Okay, congruent central angles. So first theorem states, if central angles within circles within the same circle, and then I'm going to put this in parentheses, maybe not, or congruent circles, if central angles within the same circle, congruent circles are congruent, so I'm going to write this as an if-then, then the arcs are congruent. That's it. So I'm gonna highlight this one blue. If central angles are congruent, then arcs are congruent. So I'm going to call this BC and DE because we could see their central angles are in fact congruent. 50 degrees is congruent to 50 degrees. Their arc measures will also be congruent. So we have here, for example, angle, this is BAC. Is congruent to DAE, then the measure of the arc measure of BC is going to be congruent to the arc measure of DE. Okay? So hopefully that's straightforward, because that's going to be 50 degrees as well. BC should be 50 degrees. DE will be congruent to BC. We could also technically say that about the chords. Okay? And technically, we could also say that about their arc lengths. The arc lengths will also be congruent. So here we go. Next one. If central angles are congruent, once again, within same or congruent circles, then the chords are congruent. Okay, so in this example, we'll see BC, I'm sorry, we have, for example, same angle measures, BAC, is congruent to angle DAE. As a result of this, BC, the chord BC, will be congruent to DE because they have the exact same central angle, they have the exact same arc measure, they will have the exact same chord length. Okay, so if I said, for instance, this, if I said this was 5 inches, then DE would also be 5 inches. These would be congruent by definition, okay? Now, we obviously don't have to say that. I'm just going to take markers there just to show congruency. All right. Now, if we have congruent chords. If we have congruent chords, so this is a very different, not a very different theorem, it's kind of the reverse. If we have congruent chords, so if two chords are congruent within same or congruent circles, then the arcs are congruent. Okay, so here's our version of it. So here's our circle. Let's call this A again. And we're going to put 2 different chords here. Let's put this a little bit here. Draw some chords. That's not a good chord. Here we go. Here's a chord here and a chord here. Let's call this BC and ED. All right, so here's your example of it. Example, if BC is congruent to ED, then BC, the arc BC, even the measure or the arc, is going to be congruent to ED. Okay, if you want to just do some highlighting for this, you absolutely could. BC is congruent to ED. Then we could say the arc BC and the arc measure will be congruent to ED in both cases, arc length and arc measure. All right, so that's all I have for you today. If you do have any questions, please let me know, and I will see you in the next one. Bye.